And I think we're ready for our final lesson in Unit 2, talking about roots. And what we have in front of us is a certain graph. They tell us it's a cubic of the form ax cubed plus bx squared plus cx plus d. And all we have is the graph right here. And the very first thing to notice is this thing. That's your y-intercept. That means when x is 0, you get a y value of 1. So all of these x's up here are zeros. So 0 plus 0 plus 0 plus d, so it equals d, needs to equal 1. Now, the only other thing that we know is a represents your leading coefficient. So as you look at the clues, it's going up and to the left and down and to the right, which means that our leading coefficient should be negative. Okay, so you might want to give a little bit more of a reason than, I mean, obviously I verbally, said what these represent, the y-intercept, and this is because the end behavior. Okay, obviously I would like you to be a little bit more specific about the end behavior, how, as x goes to negative infinity, they call it g of x is going to infinity, and same thing as x goes to positive infinity, g of x is going down to negative infinity. So what else can we conclude about the roots? Well, I guess the one thing that we can say is that there's one positive root. I would not say it's like 1/3 or 1/2 or whatever number you're thinking it is. Positive, maybe even say a real root. The reason why I'm bringing that to your attention is because how many imaginary must there be then? Well, if it's a cubic, we need a total of 3. So 2 imaginary roots. This one was based off of the graph. This one is from the fundamental theorem of algebra. And on the next part, what's the maximum number of sign changes that the equation of g of x could possibly have? I mean, I would go ahead and say that you could have 3 sign changes. The only issue is you have a negative, so then it would have to be a positive, negative, positive, which could happen. But I don't know for sure if it's 3 or 1 sign changes. It's definitely not 2 though, because if there are only 2 sign changes, then it would be 2 or 0 positive real roots, and we definitely have 1. So some sort of reasoning like that. All right, so now what they have is they give you a little clue in this problem. If the coefficient of the linear term, by the way, the linear term is with the x, because that's how we create lines, so negative 3x. They also tell you g of negative 1 equals 8. Find the equation of g of x. So we can piece this together, and that's through the use of synthetic. Because we don't know the a value, we don't know the b value. By the way, I'm looking at the equation a, b. But now we know c is negative 3, we know d is 1. c is negative 3 and d is 1. We also know that g of negative 1 will give us a y value, y value of 8. Or we can use synthetic this way. And, well, let's actually do the math then. Bring the a down, then you have negative 1, adding straight down, negative a, which is b minus a. As you multiply by negative 1, I hope you're okay, I'm going to just switch it around. So we have a minus b minus 3. As we multiply by negative 1, we're back to b minus a, but now plus 3. So adding that straight down, I would say that b minus a plus 4, 1 plus 3, needs to equal 8. Okay, so, well, we have an issue. We have 2 variables, 2 unknowns with 1 equation. So there must be another clue somewhere in the problem, and I don't know if you noticed, but we already used this clue to figure out that d equals 1. I'm looking for another place where it clearly crosses at a definite ordered pair in the problem. I would say it definitely crosses at 1, negative 2 on that graph. So I can use that. So when x is 1, I can set up the same synthetic, except it needs to equal 2. Sorry, negative 2. And that's from using the graph. So the graph told me that. So it's the same arithmetic though. A plus b. But now it's easier because you're multiplying by 1. At least this is my opinion that it's easier. And adding straight down, I see that we have a plus b. 1 minus 3 is negative 2. Must equal negative 2. So I would rewrite these two equations. A plus b is equal to 0. And I'll switch colors. This one I would subtract 4 over, so I'm looking at negative a plus b is equal to subtract 4 over 4. So you can cancel out those a's. So we have 2b is equal to 4, which tells me now that b equals 2. And now I can use that and go back to this equation. So a must equal negative 2. It's the only way to add a plus 2 will equal 0 if a equals negative 2, which confirms, remember earlier we said a was a negative number, that we have the equation negative 2x cubed plus 2x squared minus 3x plus 1. That is the equation for g of x. Personally, I think this type of math is fun because you kind of just get to play around and come up with your own system and then use what you learned in Algebra 2 and answer it. So feel free to pause the video or try this on your own, or maybe look at the next problem, see if you can try that on your own. And we're trying to piece everything together. We're at the end of the unit, so there's a test coming up. All right, so here's another problem. They're reminding you about the Descartes rule of signs to find the possible combination. So that's creating a chart. So again, we have a negative to a positive to a negative to a negative. That is 1, 2 sign changes. So there's 2 or 0 possible positive roots. Now if I were to look at, I typically do this in red, but if I were to do this with negative x now, I would just do the math in my head because a negative x to the 4th power, let's go back to the original sign. Negative x squared goes back to the original sign. And then plus 2x minus 2. But again, a positive to a negative. I don't know what's wrong with me. It's a negative to a positive to a positive to a negative. There are 2 sign changes again. We don't count from a positive to a positive. That's not changing sign. So we have 2 or 0 negative roots. The fact that we have a constant says there's 0, 0 roots. And with a 4th degree polynomial, it could be 4, 2, or 0 imaginary. So our sign chart, I'll just make it over here, and we're going to try and squeeze it in. Positive, negative, 0, and imaginary. It could be 2, 2, 0, and 0, or it could be 2, 0, 0, and 2, or it could be 0, 2, 0, or 2, or it never crosses the x-axis, and we have all 4 imaginary. So as I typically do, when they ask you to use a graphing calculator to sketch the graph, I'm going to go to the answer key. And as we're looking at that curve, this definitely crosses twice to the left of 0, to the left of the origin. So there's 2 negative roots. And there are no positive roots, so that means that we're left with imaginary roots. So going back to we had this picture. I forget where it was. We had two roots that were to the left. It's a very lame graph. But yeah, so our roots, it crossed the x-axis twice to the left of the origin. Now the next part is asking you to use your graphing calculator to find the relative mins and maxes. There's a lot of key presses to get there. Maybe I'll just show you with the graphing calculator. Alright, so I went ahead and graphed it with my graphing calculator. By the way, if you mess up anywhere, go to y equals. Make sure you hit the negative sign when you want the negative. Notice how your calculator doesn't understand the difference between a negative and a minus sign. And then if you go to your graph, you can actually see the better graph than what I drew. You can clearly see it crosses at -2 though. And by the way, you can change your window to fit the screen. This is how you change it to move to the left, to the right, up or down. And if you ever get lost, you can always go back to the home screen by hitting zoom 6 is the standard window. And then I'll draw it again for you. So now, how do you find the mins and maxes? What you have to do is hit this button, second trace, and you have to calculate the maximum value. And then what you need to do is move your cursor to the left until you get to the left side of the maximum, hit enter, move the cursor to the right side of that maximum, hit enter a second time, and then as close as possible, hit enter a third time, and the graph will actually tell you the max value, -1.366, 2.848. So go ahead and write that down. The issue with the graphing calculator is you have to do this multiple times. It can only do one max at a time, so repeat the process. Second trace, fourth option is your maximum, and then you have to move it again to the left of your maximum, so about right here. Enter, move it to the right of that maximum, hit enter, and then move it back to the closeness, and you get. Now here's the other issues. Your calculator is doing a bunch of arithmetic over and over again, so it rounds this answer, but I think it's safe to say that this number is exactly 1, -2. And you could confirm it if you went back to, and you plugged in 1 for all these x's. You'd have -1 plus 3 minus 2. 0 minus 2 is -2. So your graphing calculator is not your best friend here. And then one more time, except now to find your minimum is option 3, but it's the same button pressing. Left of your minimum, hit enter. To the right of your minimum, hit enter. And then at your best approximation, hit enter a third time. And this is your minimum value on your graph. So just as I typically do, I'm going to go to your answer key and share with you the answers. And the reason why we're asking you to do that is then to ask you for points of inflection again. Remember, we're piecing everything together in section 9. So as you recall, the approximate midpoint of your mins and maxes will be your points of inflection. And then you can answer where the graph is concave up and where the graph is concave down. Remember, concave up is an upwards U, and concave down is a downwards U. So I'm going to leave it on this screen for a little bit, so you should hit pause before it is cut off.